Hello, I'm Roman and welcome back to another video in the series of neural networks from scratch in Go, where we dive into the bare bones of what is the neural network, from which part it consists from, and how you operate with them. And to do this, we're using this book called Neural Networks from Scratch in Python, but as you can guess from the name, from the name of the series, we're using Golang. And in the previous video, we introduced the layer struct. So we still, we not actually on the chapter 3. Oh, do we? Oh yeah, we actually finished with chapter 2 last time. So we had the layer right now, and we're going into chapter 3. And the first thing we're going to do is to introduce, we're going to rewrite this part of the code into something different. So right now I have everything inside one function, and I want to have something like this. So it takes the layer params like weights and the biases, it takes input metrics, and it returns the output. So then we can declare as many layers as needed, and we can, chain them, take the input, pass it into the first layer, get the output, pass it into the second layer, and get the output. And as the book said, at this moment, we have only inputs and 2 hidden layers, so we actually don't have an output layer. So let's go. Where I left this to-do that I want to move it into the separate function. And actually, what I want to have a function that I'm not sure how to call it, but okay, process layer, let's name it like this for a while. And it will take 2 things. The first, it will take the input, which will be actually I need to check. Will it be the dense? Yes, it will be the mat dense input, which could be the input from or the model itself or the output from the previous layer. And the second one, we're going to have the layer. And what we want to return? Dense, right? We're going to return a new dense. Mixed names and unnamed params. Actually, need to check how to metrics. Oh, so it's the opposite. Okay. Like this. Layer. Okay. What we're going to, so we'll have the layer. I think we need to move this, right? Let's call it inputs. Yes, we don't have the layer 1. No, we need to return result. Cannot use inputs variable of type matDense as matrix. Can't use inputs variable of type matDense as matrix value in arguments to resolve that part. Maddens does not implement matrix. How it worked before? Oh. I'm confused. This is the Maddens, so we used it. Right. Now it tells me that, well, yes, it obviously needs to matrix this. The first layer 1, it will be, it should be layer 1. Mid. By the way, let's do it like this. I want to store it as a new dense, well, as a dense matrix, and then I want to transpose it here. And okay, I will deal with this later. So first I want to define a way we will create a result matrix. So first, so rows is defines number of neurons for the layer. So it's actually number of rows, right? I think it should be like this. And calls defines the number of inputs, number of neurons from the previous layer, which is still it should be like this. Number calls, number rows. Okay. There is still a problem with the types, and it tells me that we cannot use maddens as a matrix value in argument matrix. Then doesn't implement method add has pointer receiver. Okay, but how can I create inputs matrix? In the row matrix returns the blast type, right? Marshall, that's The only thing that can be an implicit transpose by returning the receiver's inside transpose. I need metrics. Matrix is the basic matrix interface type. Mutable. Okay, oh, it's effect dense. Where is that? Where is dense? Clone from makes a copy of into the receiver. Diagonal divides inverse. The thing that I don't understand why it worked before. Why it works here. Okay. Gotcha. Okay. Okay, we're removing all this, and then we declare layer 1 output process layer inputs and layer 1, right? Then let's run. Okay, mismatch. That's good. Yes. Yeah, I thought I will do something. So I need... So the number of inputs 3, number of weights up. Yeah, because... Wow! 33. Okay. But why? Oh, yes, because... yeah. Yes, let's check the result. And actually, I remember there was an add function, right? Do I record? Yes. There were an add function to the matrix. I think add. So what it does, adds A and B element-wise, placing the result in the receiver. It will panic if two matrices do not have the same shape. And then the question, will they panic? I mean, should they have the identical shapes, or they can be propagated like NumPy does. So yeah, just let's try. So we can use the result, and we can take the layer biases and no. Interesting what I did. Okay. So let's see. Okay. Mismatch. Okay, so we're still doing it manually. I'm curious if there is a way to make it, you know, faster, or at least with the existing. Yeah, probably not. Okay, let's leave it as it is. So let's take a look again. We should have where it was. Okay, we should have this result. We have, so right now we have what we did. We have the inputs, right? We have the definition of the layer. I mean, sure, it's not, maybe that's not that convenient to have it in a one row with, like, I mean, visually having the two-dimensional array will be better, but I mean, okay. We don't have like big things here. Actually, interesting. I mean, should be dense. Okay. So the next thing we want to do is we want to stack. Well, I want to chain this. So in order to do this, I need a second layer, right? It will look like this. Okay, let's change biases first. This is the biases. Then we're going to put weights first. Second. Third. Right? So then we need to calculate the second. But what we're going to do? For the second layer, we need to have the layer 1 output as an input. So here it should be like this. And here we pass the second layer. And as a result, we should have, well, first it should work, but we have a dimension mismatch. Oh, right. That's true, because this is 3 by 3. So that's correct. Okay. So we have the very simple neural network with inputs and actually batch of the inputs. So we can treat it as, how much we have? 3 rows, 3 passes through the neural network. Because, well, if you take a look at the input, it should take one set of the 4 numbers and then pass it through hidden layers. So this is what we have. Then we can go next. And I think here there will be some theory. And I'm going to check it, but I'm not sure if I'm going to implement those things. Because I'm just quickly then layer dense, full code. Activation function. I think this will make more sense to me, but activation function, blah blah blah. Linear activation function with hidden layers, relu. Yeah, I'm going a little bit further to see when we will. Okay. If we actually going to use this, looks like not. Okay, so this is all about the activation functions. Calculate network error with loss. Probably here we will start to combine things together. Okay, let's get back. Let's not skip anything. The only problem is with the data. I'm not sure where to get it. But okay. Next, rather than training data. Next, rather than hand typing in random data, we'll use a function that can create. We will use a function that can create nonlinear data. What do we mean by nonlinear? Linear data can be fit with or represented by a straight line. Example of data, orange dots that can be represented fit by a straight line. Well, yeah, we can see that the data goes in this direction, or in this direction. I don't know the orientation of this line, but yes. Nonlinear data can be represented. Nonlinear data cannot be represented by a straight line. This is clearly some, I don't know, not linear data. If you were to graph data points of the form xy where y equal the function of the x, and it looks to be a line with a clear trend or slope, then chances are they are linear data. Linear data are very easily approximated by far simpler machine learning models than neural networks. This is what I've been talking, I think, in the first video, that machine learning is not only about the neural networks. There are other algorithms and approaches what you can do in the machine learning. And neural networks is just one of them. And I know that there is a difference between neural networks and deep neural networks. What other machine learning algorithms cannot approximate so easily are nonlinear datasets. To simplify this, we have created a Python package that you can install with pip called neural networks from scratch. The NFS package contains functions that we can use to create the data. For example, from NS datasets, import spiral data. The spiral data function was slightly modified from, which is a great supplementary resource for this topic. Generating some data. So I guess they implemented this one. X and Y, then number of classes, dimensionality, number of points, range. Okay, maybe you will typically not be generating training data from a function for. You will have an actual data set. Generating a data set this way is purely for convenience at this stage. We'll also use this package to ensure repeatability for everyone using an FFS init after importing the NumPy. That's three things. It sets the random seed to 0, creates a float 32D type default, and overrides the original dot product from NumPy. All of these are meant to ensure repeatability results for the following alone. The spiral data function allows us to create a dataset with as many classes as we want. The function has parameters to choose the number of classes and the number of points observations per class in the resulting nonlinear dataset. For example, if you trace from the center, you can determine all three classes separately, but this is a very challenging problem for a machine learning classifier to solve. Adding color to the chart makes this more clear. So this is one spiral. This is the second spiral, and the green this is. Okay. Keep in mind that the neural network will not be aware of the color differences as the data has no class encoding. This is only made as an instruction for the readers. In the data above each dot is the feature, and its coordinates are the samples that form the dataset. The classification for the dot has to do with which spiral it is the paroid by grouping. Those colors would be assigned a class number for the model to fit like 0, 1, and 2. Now that we are no longer need to hand type our data, we should create something similar for our various types of the network layers. So far we have only used that what's called a dense or fully connected layers. Okay. Yeah, probably we'll rewrite it in this way. I just want to check. Continue dense layers calculate the random initialization of the weights. Okay, dun. I'm curious where we will use. Okay, this is the forward that I have this function. Weights, dun. Okay, create the data set. Okay, so the next thing I actually need to perform a forward pass for our training data through this layer. Okay, so what we full codes. Okay, so the next task I need to do is find this package. I mean I will have the differences with the book for sure, but I need to implement this function. I need to implement this spiral data function, they told that it's slightly modified from here. And they have some, well, this is specifically for the NumPy because I think it uses the NumPy under the hood. We need to find a way to plot things and somehow show the results. Okay, so let's write. First, I'm going to do first spiral data, and then find a way to plot the data. Okay, I think I have around 20 minutes left, so let's find this. What I want to do is to, okay, probably this one. Yes, spiral data. Okay, let's find this function. Tutorial, no. No. Spiral. Okay. So it takes really interesting what it returns. Oh, okay, so it returns the two arrays. So in my case, okay, yeah, let's start. One. Shouldn't they call it create? Spiral data from enough datasets input spiral. C for the code. Skynet is coming. Okay, source. Number of points. So this is the number of samples. K is number of classes. D, dimensionality. Okay, looks like I need to NumPy zeros. Okay, I'm curious what it returns. Okay, but no, NumPy 0. NumPy zeros. Okay, it gets the shape. So the shape here will be samples multiplied by classes and then 2. Okay, func. Let's go spiral data. we have samples, which is int, right? We have classes, which is int. And it will return two denses, right? Just to please the compiler. No? Syntax expected. This? Okay. Okay. X. It will be new dense. How many rows? How many rows? It will be samples multiplied by classes, 2 columns, right? And no data. Have y. Oh, and I will need to zero it. Okay. What is x? What is y? Classes 3, samples 100. Okay. Okay, let's zero. Zero sets all of the metrics to 0. Okay. Actually, x and y will return, right? Then for class number in range, okay, for class number equals to 0, class number less than classes, class. What is IX? Actually, manual conversion from the Python into Go. It's rather interesting. Okay. Okay, it creates the range from samples multiplied by the class number, samples multiplied by class number plus 1. Okay, can I have the... Why you're jumping here? No. I have something weird with the top. I will figure. Range. Does Go have something like range? Returns a list with numbers. Okay. And what we're taking? We're taking samples. What is happening? Okay, class num. Well, yeah. Expected operand found. Oh, okay, so I cannot. So I guess I can do only things like, or I know how I can use the range. While the maximum examples, can I do something like no? Okay, where I'm using. Oh, okay. Okay, it identifies the range. So basically, then I will need to iterate over. Okay. Use range to iterate. Okay, so in my case it will be 4. I don't need the index. My index will be actually expected. Where do you expect it? Where? No, I want to generate the sequence of the numbers. That's it. Okay. When iterated over a slice of the map, you might try. No. Okay. Go blank creates range of indexes. I'm giving up. Go loop. Well, okay. If I cannot create the range, let's do simple loop. But basically this is what I will need. That will be just a basic loop, right? And I will have ix equals to... Oh no. Wait. Ix equals to class number. Class number. Less than... no, not the class number. Ix less class number multiplied by samples. Ix less than samples multiplied by class number plus 1. Ix plus... I wrote a loop. Okay, so then okay, what is linspace? return evenly scaped numbers of a specified interval. So you define the low end and the high end, you define the number of values, and it evenly distributes it, right? And it evenly distributes it. So we have, okay, so we have values from 0 to 1 by number of the samples, and it should equally distribute it, right? And then we have the same for, this is the R, and it will be an array. Then we have T, which also will be an array. Okay, right now I will just try to understand this code, because I'm always almost 50 minutes and I actually need to go soon. So what it does, it creates the range that is used here, so it should be possible to replace it with a simple loop. Then we create an array of evenly distributed numbers between 0 and 1 by number of samples. Then we're doing the same. The only difference that we'll have the class number multiplied by 4, and between the class number multiplied by 4 and class number plus 1 multiplied by 4. For example, for the first one, for the first class, it will be 0 and 4. And then evenly distributed with samples. Then we add some random, I think the nprand returns the array by the shape. Return a sample or samples from the standard normal distribution. Okay, so it takes the, so if we just call it, if we pass the number, it will get the dimension. So, right. So it will return even randomization from normal distribution by the number of samples, so multiplied by 0.2. So as the result, T, we will have the, for the first class, we'll have numbers evenly distributed between 0 and 4 by number of samples, then added some random value multiplied by, I think that's just to decrease the contribution of the random value into this one. And then what we are going to do, there is X. So, okay, Y is just a class number. Oh no. Okay, for this set, for this range, it sets the class number. So in Y, we will have just the class number. I think so. We can even do it like this. So Y at like set boom, 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 boom. So ix 0, and the value will be the class number. Class number. Maybe I shouldn't return it as a dance. Maybe just a... Okay, I will convert it for now, but then I will think, because I don't need to... Then we have x set, it will be okay, 0, it should be, and 1, there should be, I think, no, in T. So that should be like this. We will calculate, we'll create an array for R, we'll create an array for T, and then we will have actually another we'll have a bunch of the loops, because R multiplied by sinus from T multiplied 2.5. In the second value, we'll write the cos value. And what is NP? Translates slice object to concatenation along the second axis, which is useful because it's common occurrence. In particular, arrays will be stacked along their last axis after being upgraded to at least two-dimensional with once post-appended to the shape. Column vectors made out of one-dimensional arrays. Okay, so I think we'll need to merge them somehow, but we'll see. Okay, that's all for today. I wouldn't say too much progress, but the first thing first we wrote this, so instead of having just one layer, we actually can add as many layers as we want. We still don't have the output layer, and I think what we're doing right now is just a precondition to this. I really want to dive into this spiral data. It's a little bit, I would say, away from what the actual goal of the neural network is, because right now I'm just trying to implement the data generator, the function that generates some data, but it will force me to deal with the, well, actually not with the functions itself, although I will need to, deal with how to use some math stuff. I initially need to check GoNum. Maybe in between the videos I will check the documentation of the GoNum if it provides something more convenient to this. But the most important that I will need to use something instead of the matplotlib to show the data. And I think I will need to use this a lot in the context of the book. But for now, don't forget that I have the main channel where I talk about various things around the tech industry. So yeah, don't forget to check it. You'll find the links in the video description, and I see you tomorrow. Bye-bye.